Here are two different velocity and time graphs. This one shows constant velocity over 3 intervals, and this shows an increasing velocity at an increasing rate. It's getting faster as it goes on. So if you want to know the distance you're traveling for constant velocities, we've been doing that since middle school. If you went, let's say, 10 miles an hour for an hour, 15 miles an hour for an hour, and 20 miles for an hour, you would know exactly what distance you traveled. Mathematically, it's literally a height of 10 miles per hour times a time of 1, which creates this rectangle that you can find the area under the curve. And literally, integration in general means the sum of the amount of rectangles. Now, you're going from data point of 1 to 3, you're creating 3 rectangles. The height of the rectangle is f of, let's say, t for time, for an unknown I value, right, 1, 2, and 3, times the delta. And the sum of those triangles, we're looking really eventually to take the limit as the amount of rectangles goes to infinity, because we know the more rectangles we have, the more accurate it is. We could even do it with trapezoids, but even this trapezoids would not be exact. So really, if we start to consider the sum as we go to an infinite amount of rectangles, that's why this officially would be, let's say, for n rectangles, because right now it's 1 to 3, but really if we were to split this up, instead of going by ones, we'd going by halves, we would have 6 rectangles. Right now it wouldn't change the answer, but as we create rectangles here, absolutely 6 rectangles would be better, because let's say we're doing right-hand sums. So right now right-hand sums are an overestimate for an increasing function, but if I made 6 rectangles, it would become more accurate. And then of course, the idea is to make the amount of rectangles go to infinity, and then we will have the exact area under the curve. And so that really is the definition of this symbol, the integral. It is a thin, tall S, really meaning the sum of the space from A to B, which we've talked about. From A is 0 to B is 3. That's why we have this formula. B minus A over delta t is the amount of rectangles, or B minus A over the amount of rectangles is delta t. You can kind of use it either way. But the integration from A to B of some function, y is the height, times the change in time, which is your delta, is basically by definition the limit. Now if you start from 1 and go to n, you are doing right-hand sums. If we were to start at 0 and go to 1 less than the total, we are still going to look for the limit as we go to infinite rectangles, because whether we're doing a right-hand sum, which is when you go to the last piece of data, or a left-hand sum where you're dropping the last piece of data, you still will equal the definition of integration. So with that intro, we can start using the integral symbol.